Hello students, let us solve one more problem from Csir-Net. The topic is thermodynamics, and in the question says you have a vessel has two compartments of volume V1 and V2 containing the ideal gas at pressure P1 P2 and temperature T1 T2. So you have a vessel where you have two ideal gases. You have a P1, and here pressure is P1, volume is V1, and temperature is T1. And here the gas has a volume P2, volume V2, and temperature T2. Now, if we remove this compartment, then what will be the final temperature of the system? So if I remove this partition, so of course there will be pressure P, volume V, and temperature T, and we need to calculate the temperature. Now, we have to, in order to solve this problem, we have to understand that macroscopic properties either can be classified as extensive quantities or intensive quantities. So you have a macroscopic properties. Say they can be extensive. These are properties, and they can be intensive. Intensive means like temperature, pressure, temperature. They are intensive quantities. They do not amplify, or they do not increase with the size of the system. Like if I have a temperature T1 T2, the final system will not be like T equal to T1 plus T2. So they are not in additive in nature. While extensive quantity, they are in additive in nature, means they get add together. So for example, your entropy is additive. If two system have an entropy S1, S2, the final system will have an entropy S1 plus S2. Similarly, you have a internal energy, volume, number of molecules, or number of moles. They all are extensive quantities. So in this case, when we remove this partition, the number of moles will be gas. Say number of moles is here N1, number of mole is here N2. The final number of mole will become N1 plus N2. And we know the kinetic energy or internal energy of the ideal gas depends only on temperature. So that will also in additive in nature. So that will become U1 plus U2. So these two expressions can be used to find the final temperature. So let us calculate. So say we have a number of moles n. So n can be written as n1 plus n2, already written. Okay. Now n1 is what? N1 is your P1 V1 T1 plus P2 V2 by T2. This can be used, and this equation can be used by gas law. Okay, gas law. What is the state of the gas? State equation. So this is N1, P1, V1, T1. Similarly, I can write for N2. And now kinetic energy U is given by F by 2, F by 2, F by 2 N number of moles R. This is the final temperature. Okay, I'm writing this U. And this will be equal to U1 plus U2, that is F by 2 N1 R T1. This is the kinetic energy of the ideal gas, purely temperature dependent. And this is the only internal energy. U2 will be F by 2 N2 R T2. So from here, I can write my final temperature will be F by 2 will be cancelled out. R will be also cancelled out. So N1 T1 plus N2 T2 divide by N, and N is your N1 plus N2. And here now you can write the value of N1. So this will be only remaining here P1 V1. This will be P2 V2. And this will be P1 V1 by T1 plus P2 V2 by T2. And this is option C. Option C is the correct answer for this question. So this way, simple way, by knowing the nature of the thermodynamic properties, you can solve this kind of questions. Thank you very much.